doesn't work?
Well,
So that's actually a really good question, and as some people may not know, water itself actually doesn't have any cleaning properties. So when people are making soap, they like to call it saponification, the name for a chemical reaction between an acid and a base to form a salt. When you make soap using the cold process soap making method, you mix an oil or a fat, which is your acid, and then mixing it with a base to form a salt. And then the salt we would call soap, and soap using to wash your hands, to clean the laundry, or whatever you use it for. And soap is derived from triglycerides, and then people in chemistry, when they are making soaps, they like to use the term the saponification of triglycerides. And so you may be asking, what are triglycerides? And triglycerides are high molecular mass fats and oils, which are esters, which can be saponified in basic solutions to give soap and glycerol. So, as you can see, this is glycerol trioleate, which is a major triglyceride in olive oil. And olive oil is actually considered an acid when making soap. And so, as you can see on the top, the ester bond, which is the oxygen and the double bonded oxygen, the ester bond connects the tail to the backbone. And when triglycerides are treated with a strong base like sodium hydroxide, they undergo a saponification reaction, as we talked about earlier, which leads to the breaking of the ester bond and the formation of glycerol and fatty acid salts. And fatty acid salts would be considered sodium, which is actually Na, and a salt being soap. So as you can see right here, this is actually what would happen in the reaction when making soap. And so right here we have an Na plus and we have an O minus on the bottom. We have a polar side and we have a non-polar side. In the polar side we like to call it hydrophilic, and on the non-polar side we like to call it hydrophobic. Non-polar molecules dissolve in non-polar liquids like oils and is also attracted to grime, and polar molecules dissolve in polar liquids like water. And as you can see on this picture, soap actually has both. And so that's why it becomes such a good way to clean off things from your hands, from your face, from your clothes, and from your hair. It acts like a sort of a bridge between the oil and the water. And when dirt comes in contact with the soap molecule, the hydrophobic tail attaches itself to the dirt. So therefore we use soap to remove grime off of our hair, our face, our hands, and our clothes. So that was actually a really good question, and I hope you figured out how soap actually works.